Another operator we can overload is the subscript operator. And that is the square brackets we use for accessing individual elements in an array using an index. So if you have a class that behaves like an array, we can define the subscript operator to provide access to individual elements in that class. So back to our project, let's add a new class called array. Now, in reality, you probably never have to define an array class because we already have this in the standard library. But implementing an array from scratch is a great exercise for you to practice a lot of concepts you have learned so far. So let's add this class. Now here we're going to add a constructor that takes the initial size of the array. And for that, we're going to use size t. We talked about this in the previous part of the course. So size t is a type or a data type that represents the size of the largest object the system can handle. Often it translates to unsigned int or unsigned long, depending on the compiler. So we're going to use size t and call this parameter size. Now, this type is defined in a header file called cstd_def. So C standard definition. In this file, we have a bunch of definitions like size t. Now, in this class, we need an integer array for storing a bunch of integers. But we cannot declare an integer array like this because the size is determined at runtime. So at compile time, the compiler doesn't know how many elements it should allocate for this array. So to solve this problem, we need to allocate memory dynamically. So let's generate the definition for the constructor. Now C-line is suggesting to make this constructor explicit, which I believe is a great idea. Now let's generate the definition. Okay, so over here, we're going to use the new operator to allocate an integer array with this size. Now, you know that this operator returns an integer pointer, okay? But we don't want to store that as a local variable in this function. So instead, we want to make this private attribute an integer pointer. So integer pointer values. And then we set this right here. Now here we should also store the initial size because an array should always know its size. So let's add another private attribute of type size t called size. Now, back to our constructor. Here we set this size to size. Okay? Now, because we have allocated memory dynamically in the constructor, we should release it in the destructor. So let's add a destructor here and then generate the definition. And here we use the delete operator with square brackets to delete the values pointer. So now we have an array class and we can use it like this. So first we have to include the array header file, and then we can create an array object. Let's give it the initial size of 10. Now the problem we have is that we cannot access individual elements in this array. And this is where we need to overload the subscript operator. So back to the array class. Here we're going to add the subscript operator. Now the return type has to be an integer reference because with this operator, we'll be accessing an existing integer in this array, okay? Now what about the parameter? Well, the parameter has to be an index, and the largest index we can have is size t. So the parameter should be of type size t called index. Now let's generate the definition. Okay, now just like before, I want to move the ampersand next to the type better. Now here we need to validate the index. So if index is greater than the size of the array, we have to throw an exception. So we can say if index is greater than or equal to the size of the array, then we need to throw an exception. But why am I including the equal sign here? Well, you know that the index of the first element in an array is 0. So if the size is 10, the largest index we can pass is 9. So if we pass index of 10, that is outside the boundary of this array, right? Now here we need to throw an exception. We talked about exceptions briefly before, but we have a comprehensive section about them later in the course. So here we're going to throw an exception called invalid argument. Now this exception is defined in a separate header file, so we need to include it on the top. It's called std except. So all the basic exceptions are defined in this header file. Now we throw an invalid argument exception, and here we need to qualify this with std. And here we pass the name of the invalid argument, which is index. Otherwise, if the index is valid, we're going to provide access to values of index. As simple as that. So now, back to our main file. We can set the first element to 1. Now to verify that it's set properly, let's print it on a terminal. Good. Now, what if we pass an invalid index, like 10? Now our program should terminate. There you go. So our program terminated with an uncaught exception. So if you have a class that behaves like an array or a collection of objects, we can implement the subscript operator to provide access to individual elements in that class.